So far, so good?
So you switched out the denominator, but it's like the same way.
The denominator is different because when x goes to 1 minus, then x minus 1 is negative. So if x is, I write it here, if x is less than 1, then x minus 1 would be negative. So when you want to remove the absolute value for x goes to 1 minus, it would be minus x minus 1. But minus x minus 1 is just 1 minus x. So the top is 3 times 1 minus x, right? This is 1 minus x, this divided by this is just 3. So the other question was this limit of x to the power n minus 1 over x minus 1 when x goes to 1. And I said that n is a positive integer, right? So here we are going to use this algebraic identity that x to the power n minus 1 is equal to x minus 1 times x to the power n minus 1 plus x to the power n minus 2 plus x plus 1. For example, if n equal to 5, then x to the power 5 minus 1 is equal to x minus 1 times x to the power 4 plus x to the power 3 plus x squared plus x plus 1. We have more general formula, so more general. This is x to the power n minus 1. So, but in more general formula, we can have x to the power n minus a to the power n. And this is equal to x minus a. So here a is 1. X minus a times x to the power n minus 1 plus x to the power n minus 2 times a plus x to the power n minus 3a squared plus x a to the power n minus 1 n minus 2, sorry, plus a to the power. So each time you give one exponent to a and you decrease one exponent from, you remove one exponent from x. So here, these are the identities we need. In particular, we need this star. So let me rewrite the top. On the top, you have the limit x minus 1 times x to the power n minus 1 plus x to the power n minus 2 plus x plus 1 divided by x minus 1. Now you can simplify x minus 1. So they cancel out each other. Now here you have x to the power n minus 1, x to the power n minus 2 plus. But when x goes to 1, each of these terms is equal to 1. Because 1 to any power is just 1. So you have 1 plus 1 plus 1 plus 1. How many terms you have on the top? So here you can count. So this is x to the power 1, x to the power 2, x to the power 3, 2, x to the power n minus 1. So here you have n minus 1 terms plus 1, which is n terms. How many terms we have? N. Each of them is equal to 1. So this is equal to 1 plus 1 plus 1. How many times? N times. So this would be n. So I want to talk about infinite limits and vertical asymptotes. So infinite, infinite limits or vertical asymptotes. A typical example of an infinite limit is the limit of 1 over x, x goes to 0. But here we have to separate right and left limit. Because limit of 1 over x, x goes to 0, which is 1 over 0 plus, is plus infinity. And the limit of 1 over x, x goes to 0 minus, is minus infinity. And you can see this in a picture. Here is the graph of 1 over x. And you can see when x goes to 0 plus, so that means you approach the origin, x equal to 0, from the right, the y values would go to infinity, plus infinity. And when x goes to 0 minus, the y values go to minus infinity. But you can basically, instead of 1 over x, x goes to 0 plus, in more general setting, we can have like limit of 1 over x minus a. A can be any number, like 1, 2, 5, minus 1, whatever. X goes to a plus. So when x goes to a plus, that means this is equal to 1 over, so x goes to a plus. So that the denominator would be 0 plus. So by 0 plus, I mean this guy. 1 over x, x goes to 0, right? So x goes to a plus means x is very close to a, but greater than a. So it's a very small positive number. So it's 1 over 0 plus is equal to plus infinity. And similarly, the limit of 1 over x minus a, x goes to a minus, is equal, we can also write it as 1 over 0 minus, which is equal to minus. So here is a more general example, which is just a shift, a horizontal transition of this graph. So I can draw the picture for you if you want. So if this is xy, imagine that this point is x equal to a, this point. This is a, right? This point is a, x equal to a. So it would be like this. So this is a graph of y equal to 1 over x minus a. So just some caution is that here you have 1. If you have like any number like 2, 3, 5, 10, the limit, the value of the limit are the same. Except you have to be careful when you have negative number. So negative number would impact the limit, and it impacts the sign of the limit. So that means if you multiply it, if instead of 1 on the top you have -1 or -2 or -3, any negative number, so the first limit would be -infinity, the second limit would be +infinity. So if you have a negative number on the top, then it changes the positive to negative and negative to positive, obviously. So sometimes we have more complicated situation. For example, look at this example. Limit of 2x minus 3 over x plus 3. Let me begin by this before going. So 2x minus 3 over x minus 1, x goes to 1. 1 plus. So when x goes to 1, or more precisely 1 plus, so the numerator would be 2 minus 3 would be -1, right? So this limit would be -1 over, when x goes to 1 plus, so the denominator would be 0 plus. Because 1 plus -1 is just 0 plus. So this limit would be -infinity. And the same limit when x goes to 1 minus, so 2x minus 3 over x minus 1 when x goes to 1 minus. Again, the numerator is -1 over, but now the denominator would be 0 minus. So -1 over 0 minus is +infinity. So these are two examples of infinite limits. So let me give you another example. So compute this limit of x squared minus 3 divided by x plus 3, x goes to minus 3, minus. So x goes to minus 3. So when x goes to minus 3, the numerator is minus 3 squared, which is 9. 9 minus 3 is 6. So the numerator is 6. But the denominator is minus 3 plus 3 is 0. And when x goes to minus 3 minus, this would be 0 minus. So this would be equal to what? Infinity or minus infinity? Minus infinity, because this is positive, negative, it's minus. Another important example of infinite limit is logarithm. So again, recall the logarithm. And that is the limit of. So here I just put ln, but this is true for any log, any logarithm. So the limit of, as long as the base is greater than 1, like the natural logarithm. For the natural logarithm, the base is e. That is close to 2.7. Or you can have log with base 2 or log with base 10. As long as the base is greater than 1, this formula is valid. So the limit of ln or log x, when x goes to 0 plus, so we know that the domain of log is positive numbers, right? So now the question is, what is the limit of this function when x approaches to 0? 0 plus. So it is still a positive number, but close to 0. And that would be minus infinity. So the limit of log x when x goes to 0 plus is minus infinity. And here is the graph you can see in a picture. The graph of log looks like this. So y equal to ln of x, or log x. So as x, you can see, as x goes to 0 plus, the log x goes to minus infinity. Okay, so now I give you a few questions to work on. And by the way, let me repeat this. Whenever the limit of a function, when x goes to a, so if limit of f of x, when x goes to a, so positive or negative, a positive or a negative, doesn't matter, equals to either positive infinity or negative infinity, again, doesn't matter. So either cases, then we say that x equal to a is a vertical asymptote. For f. So this is a definition of vertical asymptote. For instance, x equal to 0 is a vertical asymptote for log. For example, based on our discussion, so x equal to 0 is a vertical asymptote for f of x equal to ln of x, or log x in general. Or we can say that x equal to -3 is a vertical asymptote for f of x equal to x squared minus 3 over x plus 3 for that function. So I give you a few questions. Problem. So compute the following limits. The limit of x squared plus 2x minus 3 divided by 2 minus x, x goes to 2 plus. The part A. Part B, the limit of absolute value of 3x plus 1 over x plus 5, x goes to 5 minus part C, limit of x plus cos x divided by x, x goes to 0 plus, and part D is the limit of ln of x minus 2, or let me just say x minus 2, yeah, divided by x sine x x goes to 2 plus. So here are some problems. I want you to solve it. For limits, you have to compute that this part B is x minus 5, not x plus 1. X minus 1. So on the top, I have 16 over absolute value of 0 minus. One way is just saying that it's 16 over 0 plus. Another way is we can say that if, because x goes to 5 minus, x is less than 5, right? So that if x is less than 5, then absolute value of x minus 5 is minus absolute value of x minus 5. Sorry, minus x minus 5. So if x is less than 5, absolute value of x minus 5 is minus x minus 5. Because this guy is negative. So this would be equal to, but the top is 16 over minus x minus 5. I remove the absolute value. I replace it by minus x minus 5. But here x goes to 5 minus, right? So x goes to 5 minus means x minus 5 is 0 minus. So it's 16 over minus 0 minus. That is again what? So 16 minus 0 minus is 0 plus. 16 over 0 plus, which is equal to plus infinity or positive infinity. Clear? So what about part C? X plus cos x, x goes to 0 plus. So x, when x goes to 0, x plus cos x is 1. So on the top, you have 1, right? But at the bottom, the denominator is 0 plus, because x goes to 0 plus. So this would equal to 1 over 0 plus. So equals is going to be 1 over 0 plus is positive infinity, yeah. And I leave part D for you to think about it. On the numerator, you have ln of x minus 2. The denominator is x minus x, and x goes to 2 plus. So let me tell you another important rule or theorems of the limit. It is a very important indeterminate form. And that is, so this is a theorem. And it says that the limit of sine t over t when t goes to 0 is equal to 1. So limit of sine t over t, t goes to 0, no matter 0 plus or 0 minus. When t goes to 0 is 1. So based on this, I can give you some problem to compute this limit. Based on this, compute. So A, limit of sine 2t over t, or let me just say 2x, sine 2x over x, x goes to 0. Limit of sine 2x over x, x goes to 0. And B, limit of sine of x over the square root of x, x goes to 0 plus. And C, limit of sine 5x over 3x, again x goes to 0. So an important, I want you to pause for a second and look. First of all, these limits, and all of these limits, most importantly, this one is an indeterminate form. It's 0 over 0. Because sine of 0 is 0, and t when goes to 0 is 0. So it is an indeterminate form of 0 over 0. But we accept this as a fact. This for us is a fact. We can prove it. Maybe later I will prove it. Why this is true. Why this limit is 1. But for now, we just accept this as a fact. So this limit, sine t over t when t goes to 0 is 1. And all of these problems like A, B, C, they're all 0 over 0. Similar to this. But for them, we want to use this fact. So here you have to relate this, each of them, to this equation. So we want to make use of this to compute each of these limits. Let's do it. So some hint for this guy. Sine of 2x over x. So you have sine 2x, and you can, this is exactly similar to this guy, sine 5x over 3x. So sine 2x over x, look, if you multiply this by 2, I mean, just multiply this top and bottom by 2. Doesn't change anything, right? So you just multiply denominator and numerator by the same number. But here you have this part, you have sine 2x over 2x. 2x over 2x. Similar things like t over t. So basically you can say, for instance, here you can say that you can change your variable. You can say that let, for example, 2x be equal to t. Then this would be equal to sine of t over t. But there is also 2 here. Right? But this limit, now if you take the limit, because x, when x goes to 0, here x goes to 0. But t equal to 2x, when x goes to 0, when x goes to 0, then t also goes to 0, right? Because t is equal to 2x. So this t goes to 0. So you have equal to what? 2 times sine t over t. And this is equal to 2. 2 times 1. This part is 1, so it's 2 times 1 is 2.
You just take the value from the numerator.
Exactly. So we want like sine of something over the same thing exactly. Like, for example, sine of 5x over 5x. But here you have 3x. That's fine. You can just multiply this 5 and 5. Then now can you do part C and B? First do C. And then B.